Okay, here we go again, guys. I have a short video today for you about tangent line equations. So what I want to remind you guys before we start, we're going to see a lot of problems dealing with equations of lines. I want to remind you that if I ask you to find the equation for the line that goes through the point 2, 4 with a slope of 5, that equation is y minus 4 equals 5 times x minus 2. So this is your slope. This is your point. This is like your x1 comma y1. It's just y minus y1 equals a slope times x minus x1. This is called point slope form, and this is going to be our preferred form that we use this year. Okay, now that's a great starting point. So now let's do this. Let's find the equation for the line tangent to the graph of f of x equals 3x squared minus 2x plus 6 at the point where x equals -1. Okay, now if I want to use this point slope form, there are two things that I need. I need to find the point, which is x1 comma y1, and I need to find the slope. Well, I want you to remember that slope, that m, the slope of the tangent line is the derivative. So that slope is f prime at that point x1. Okay, so in this case, they give us the value x equals 1. If I want to find the point, that's the y value. The y value is just f of -1. Okay, well that looks very easy. I can just plug in 3 times -1 squared minus 2 times -1 plus 6. So I end up getting 3 plus 2 plus 6. That's, I mean, I'd screw up, but I think it's 11. Okay, now if I want to find the slope, to find the slope, I need to find the slope of the tangent line, the derivative f prime at -1. So my f prime there is going to be 6x minus 2. So f prime at -1 would be -6 minus 2, which is -8. Okay, so keeping that point and that slope in mind when I write it out, I'm going to have my point is -1 comma 11. So my equation will be y minus 11 equals slope is -8 times x minus a -1 becomes a plus. Okay, and there, my friends, is the equation for our tangent line. Okay, and that's how you should think of any time a question asks you for an equation of a tangent line. Find the point and find the slope. We'll do one more quick example here. Suppose you have the function y equals e to the x minus 5x. And again, you want to write the tangent line at x equals 0. Okay, so with that in mind, let's take the point first. So when x equals 0, my y is e to the 0 minus 5 times 0. Remember, anything to the 0 power is 1, so that's 1. So we know we have the point 0, 1. If I want to find the slope is y prime of 0. Like always, we'll take the derivative and then plug in. So y prime here is e to the x is its own derivative minus 5. So y prime is 0 is e to the 0 minus 5, which is -4. Okay, so that's my slope. So y minus 1 equals -4, x minus 0, and there we go. Okay, so that's how we write out tangent lines. One more type of problem you might see is something like this. So I'm going to tell you, and you're going to see something like this on your homework. Find all values of x for which f of x equals x cubed minus 3x squared minus 24x plus 4 has a horizontal tangent. Now, I want to think graphically about what this means. If a function has a horizontal tangent, let's draw that out. So what that means is the tangent line has a horizontal slope. And I kind of think of this picture because it reminds me, oh, what's the slope of a horizontal line? It's 0. So if I want a horizontal tangent, that's saying where does f prime equal 0? So I'm going to set f prime equals 0. The problem told me to find all values of x. So once I've set f prime equals 0, then I will find x. Okay, so my first derivative, my f prime, would be 3x squared minus 6x minus 24 to equal 0. You could use a quadratic formula on this. It's probably easier to factor. You might recognize all these terms have a 3. So you have x squared minus 2x minus 8 equals 0. So we need two numbers, then multiply to -8 and add to -2. So that's x minus 4 and x plus 2 equals 0. The 3 does nothing. So our values there are x equals 4 and x equals -2. Okay, and that's what the problem asks. The problem asks for what were the x values where you had a horizontal tangent. Let's actually graph this just to verify. So I'm going to go over here to Desmos and graph this function. And we're going to hopefully see, do we have a horizontal tangent at the points we expect? So we're looking for x to the third power, and then let's see, minus 3x squared minus 24x, and then plus 4. Now, kind of hard to see these y values, so let's just kind of zoom that out. There we go. Okay, so looking at that, does it look like we have a horizontal tangent at -2 and 4? Oh, it does. Oh my God, everything worked again. Okay, so that's great. So that's how that works, and that's how we do this problem. So it's nice that the graph matched up and I'm not just teaching you absolute gibberish. One more thing I wanted to be aware of, you're going to see some problems like this on your homework where you have other letters as constants. So if you see like an A or a B or like an M or something, just treat it like a constant. Treat it like you would a 3 or a 5 or something like that. So let me show an example of what I mean. So if I take the derivative, so d by dx of 3x plus 4. And by the way, if you haven't seen this notation, it's d by dx parentheses of something. So this just means take the derivative of whatever's in parentheses. So take the derivative of 3x plus 4. The derivative of 3x is 3 times 1. Derivative of 4 is 0. It's just 3. So by this similar token, if you try and take the derivative of ax plus b, where a and b are constant. Okay, so if you take the derivative of a times x, well, the derivative of 3x is just 3. It's just a constant in front. Derivative of x is 1. So the derivative of ax is just a. And the derivative of b is just 0. So it's just a. So just treat the a and the b like you would a 2, a 7, a 3, any other constant, and that should help you on those problems. Okay, so that was this video on tangent lines, a couple other things. Thanks for watching. As always, hit me up if you got your questions. Enjoy.